That sounds like integrals plus Robert's chain. Pretty funny. Yeah.
I'm alright.
That's pretty bad. How are you doing here? So, I got it. Yesterday, when I did the stuff, right? I take it apart, I hand wash it.
I've done dry overnight.
Go to put it back together. Also, kind of stopper there is missing. Probably down the drain. So I'm kind of ticked because this is my water for like yeah, less than 24 hours and it's broken, right? So I take it in today and I'm up at the table and I'm like, hey, this is what happened. I get a new lid. He's like, it's probably coming. Well, that's not exactly what I wanted because this was hard. Like, the cup that I had to socially right? So here I am. Here I am. Sorry. Yeah, I share it, but when you type in a message, it generally says that, you know, hey, so-and-so is sharing. That's... When you finish your paper, you have it.
Okay. Yeah. So that
One second. One second.
Or you could, all the
Thank you so much. I mean, it's not like I'm going to have a lot of time. I actually could be surprised.
Get your notes out, please. It's all right.
How you doing, Mr. Dixon?
Good, how are you?
Tired and slightly.
I feel like that's just like standard for me.
The tired or the slightly annoyed?
All of the above. Notes out. This looks a lot more complicated than it actually is. I'll show you a couple examples, it's not bad. Oh, I have something for you too. I made a list of things that help you study. 10 questions on the gateway, and I kind of broke down, let me three of these, one of these, one of these. Told you exactly what we got there. What type of questions on the actual question. So on Tuesday, I'll definitely give you practice gateway, but this way you know, okay, I need to be studying, these things are out here. Bless you. I think it's pretty self-explanatory, but if you have a question, let me know. Derivigrals is what we're doing today. We haven't done definite integrals with reverse chain rule, but we've done definite integrals and we've done reverse chain rule. And you know enough, you could do it. That's what we're doing Monday, and we'll spend some time on it Tuesday also. Bless you. So the ones, if you were starting the con last night, there were a couple that said like the derivative of the integral type of thing. That's what this is. So derivigral is not like an official term. I've actually Googled it, but no one else, I couldn't find it. No one else calls this, I guess. But basically, they'll give you an integral, and then they want you to take the derivative of the integral. It is. So they'll give you f of x is the integral of this, and they'll say find the derivative. Well, the derivative of the integral part basically cancel out. So when I take the derivative of the integral of f of t, I end up with f of t. But you still got these numbers you got to plug in, and oftentimes they're not numbers; they're equations. So you'd be plugging in like cosine of x or x squared or something. So what you do is you plug in the top minus you plug in the bottom, but you have this extra chain rule piece because these will be functions of x, and then you're done. Like that's the whole problem. You don't have to do anything after that. You basically want to demonstrate that you know that derivatives and integrals kind of unpack each other. You end up with the original function, and then plug in whatever they give you. Again, that probably looks way more confusing actually is. But any general questions I can answer on that? So let me look at it. Let's look at a couple and see. So I'll write that down. So I just did your worksheet and hit like regenerate. So these will be very similar problems to what you're going to get. So the derivative, so they're asking, giving you f of x is defined as this function. So the x is, come to. So they're asking you to find the derivative of this. So what I'm going to want you to do to kind of remind yourself of that is I'm going to take the derivative, I'm going to write it as d over dx of the integral from negative pi over 2 to x of negative cosecant squared t times dt. Again, that looks a lot scarier than it actually ends up being. You see where I'm getting that from, though? They gave me an integral, they're telling me to take the derivative of it, so I'm just kind of rewriting that. Okay, I'm going to take the derivative of the integral. Well, the derivative of the integral part cancel out. So what you're left with then is just negative cosecant squared t. But you do still have these that you need to plug in. So negative pi over 2 to x. It's not negative pi over 2, is it? It's just pi over 2, sorry. Thank you. Okay. So then, all you're doing is like the plug-in part. But, whatever you plug in, you got to multiply by the derivative of what you just plugged in. So we're never taking the derivative of like the negative cosecant squared t. This is just locked in place, basically. We're going to multiply by the derivative of the x, which is just 1, so in this case nothing really happens. And the derivative of pi over 2, which is 0, so this is like a pretty nice one. Let me get through the problem first. So I'm going to go negative cosecant squared of x, and then I multiply by 1 because that's the derivative of the thing that I just plugged in. I'm taking the derivative. It's chain. Basically, this is your little guy, so I got to multiply by the derivative of the little guy because this problem is taking a derivative in the big picture. Minus, plug in the bottom. And here's the nice part about these. I multiply by the derivative of what I plugged in. Well, what's the derivative of pi over 2? Pi over 2 is just a number, so it's 0. So in a lot of these, that whole second part just goes away. Your answer is just that. You don't have to do anything else. Like we never even had. This looks complicated. It's cosecant squared. It's like, I mean, it's trig, but it's not really trig. You don't have to do anything with it. You just kind of unpack in the derivative of the integral and then use that chain rule piece. So yeah, we'll that.
Can you just go over how you got from the first step where you have the dx over dx and then the second step?
Here's basically what is happening there. This and this are complete opposites, so they cancel out. That means this part is left. So hold on. And then these, I shouldn't have crossed out the x and pi over 2. The derivative and the integral cancel out. So what's left is the x, the pi over 2, and then this piece here. Does that make sense? Other questions on like this one specifically or anything in general? So let's look at this one. So again, you've got to see, okay, I'm being asked to kind of do both things. I'm being asked to find the derivative of a thing that's an integral. Well, that's a derivigral, and that's this kind of formula I'm trying to show you. So I'm not in the game where you're going to be like, number 7 is a derivigral. You know, I'll say find the derivative of the integral, and you got to recognize that's what you're supposed to do. So, the derivative of the integral from x to x squared of 2 sec x tan x that's what I'm being asked to do. That's just me rewriting the problem. So this was my f, and they're asking me to take the derivative of it. So that's just rewriting the problem that they gave me. Yes. No, you're correct. That's correct. Good. So now, the derivative and the integral sign itself wipe out. Derivatives and integrals are opposites, they undo each other. So what you're left with is 2 sec t tan t, and you still have the x and the x squared. Almost imagine if you just took this bracket that you didn't cross off yet, and you like click and drag and slid it into here. You know, that's what we have there, right? Kind of the same, just on the other side. Then, my job is to plug in the top minus plug in the bottom, but I have, this was a derivative problem at the beginning, so I have to remember chain rule. So it's 2 sec of what? X squared tan of x squared times what? Times 2x, because you're taking the derivative of what you plugged in. So if you go back to that original slide, I don't know if I saved it or erased it. So when I plug in the b, I do an f of b, there's the b prime. So you're multiplying by the derivative of what you plugged in. So a gets multiplied by a prime. Find my way back to that. Okay. Minus 2 sec of what? X times tan of x times 1. So I'm plugging in the top, multiplying by the derivative of what I plugged in, minus plugging in the bottom, multiplied by the derivative of what I plugged in. I'm doing that because the original problem was a derivative, and it's a chain rule thing that's happening there. And you're done. There's nothing I can do to simplify that. So a lot of these you just do one step and you just stop. You know, if you can simplify it, you do. But that's not really the main worry at this point. Questions on that? Let's get a little easier. Yeah. I mean, so I could make this like 4x here. I mean, yeah, you could. You don't need to. You can't distribute into the like x squareds though, right? Because those are different. Any other questions on this one? Or generally, yeah, we'll do a few more. Okay. Let's see what's next. Let's try that one. This will be a little easier to simplify. Just x's. So they're asking me to take the derivative of the integral from x to x squared. So again, the derivative and the integral just wipe each other out. plus 6t minus 8. And I'm left with the x and the x squared that I still have to plug in. So plug in the top. So x squared goes in place of t. And then what do I multiply by after I'm done plugging in the top? 2x. Questions on that step there? So just anywhere I saw a t, I'm putting an x squared. We're going to clean this up at the end. We're going to simplify it. But for now, I'm just putting the x squared in those spots. Minus. So now you do it again, but you just put an x in for the t's. And then I multiply that by what? By 1, because that's the derivative of what I plugged in. So that doesn't really need to be there, but just to keep it consistent so you see what I'm writing down. And that's the problem. That's the calculus right there. We're going to simplify it, which is like with the algebra, but questions on what I'm doing up until that point. Alright. So this would be negative x to the fourth plus 6x squared minus 8 all times 2x minus negative x squared plus 6x minus 8. So you guys do some work. You guys, well, distribute the 2x and then combine all the like terms and see what you get at the very end of all of that. If you look at that sheet I gave you, there's one of these questions on the gateway. One derivative. So this would be, let's see, negative 2x to the fifth plus 12x to the third minus 16x. And if I distribute that negative sign through, then it's plus x squared minus 6x plus 8, and then just combine like terms, so negative 2x to the fifth plus 12x to the third plus x squared minus 22x, because those two will combine, and then plus 8. How many have that? Questions? All right, let me give you one from the start. I don't like do it for you. Let's try to find a. That's a good one. That looks hard. Try that. You don't make it. How do I make this bigger? Huh? Here, just so you can see it. Is that better? Not really, so? to rewrite the problem, I think it's easier to see it this way. d dx of the integral from x to x squared of negative 2t to the 1/3 times dt. And then your integral and your derivative part cancel out. This is still there though. And then you got negative 2t to the 1/3 from x to x squared. So I'm going to plug in the top. So anytime I see a t, I'm putting in the x squared. And then I multiply by the derivative of what I just plugged in. That's the chain rule piece for the x squared. Same thing with the x. So negative 2 times x to the 1/3 times the derivative of x, which is just 1. So that part's nice. And then over here, this is negative 2. You have a power to a power here. What do you do when you have power to a power? Multiply them together. So 2 times 1/3 is 2/3. Okay, times 2x, and then this distribute that negative sign, so plus 2x to the 1/3. So that's this part here. And then if we combine those, negative 2 times 2 is negative 4. And when you're multiplying, what do you do with the powers? You add them. So there's really a 1 there, which is really like 3/3. So that's where they're getting the 5/3 from. And then 2x to the 1. How many had that? I think that's a tougher one because you got like the fraction powers to deal with. Questions I can answer anywhere in there? I want to do one more. I'm not convinced yet. Oh, it's hard. Try that. It's actually not that hard. Never mind. I think I've given you about as hard as I can give you. But try that. I'd say if you're getting it right now, you're in good shape. Like, I can't really make it much worse. Jeez. Sorry. Also, make sure you're thinking about how to recognize that this is what you're supposed to do. You know, today it's easy. Today we're doing derivative rules. Every problem you do is going to do derivative rule. But do you know why you're doing it? Because you're being asked to find the derivative of the integral. So on the gateway, you're going to be able to identify that. You know, it won't be just, this is what we're doing today. Is that a victory celebration? The ones with the numbers down here are my favorite. Because that whole second part doesn't even matter anymore. So that's just setting it up, taking the derivative of the integral. And this is what I mean by, like, you got to recognize what I'm asking. So on the gateway or the AP test, you know, I'm giving you an integral and I'm asking you to take the derivative. Again, that's how you know you're doing a derivative and combining the words. So plug in the x to the third, multiply by the derivative of what you plugged in, minus plug in the negative 4, multiply by the derivative of what you plugged in, which is 0, so that just goes away. Then if you distribute, so it'll be 3x to the 5th plus 3x squared. How many got that? Questions for me? Yeah.
Okay. So,
Cool.
why would you take the derivative of an integral? Like, the integral is the opposite of the derivative, so why would you combine it? It seems like it would just cancel out. Like, why doesn't it?
Well, let's say that, I mean, again, that's theoretical, but let's say I knew the integral of velocity, but I didn't know the velocity function for some reason. To get the velocity function, I'll take the derivative.
So, like, you go backwards from the backwards to get back to the start. Kind of.
Forward from the
words to get back? But
Yeah, I know. Yeah.
Alright.
So this is your worksheet. It's one of those like you gotta know how to do it, right? So I'm not gonna come around and be like, did you do all 15? You gotta know how to do it. You have what, 25 minutes left, 20 something minutes left. Work on this. Work on your con. We have one more lesson on Monday. Con is due Tuesday to get qualified for all 3 attempts at the gateway. Sorry, I'm slamming you with work before break. No, not really sorry. Just like saying that thing I'm supposed to.
Long teacher is.
I'm fake sorry.
I'd really have like 5.
I'm way better than finals before break.
I knew that's my sister.
We should start like 2 weeks earlier and then we could
I agree.
have before break.
But I want to apply to see next year.
You can apply for a